All right, so number 1. Right. So, is it a left hand or right hand?
Right.
Left. Oh, that should go with A. Sorry. Okay, so what is A?
0.
B?
0.
6. So A is where it starts. B is where it ends. Okay, N is 6 because we have 6 rectangles. 1, 2, 3. Okay, and delta X is 1 because each rectangle has a width of 1.
Hey, I got this.
Okay?
So what's that between left and right again about where you started?
So left, your rectangle should, the top left of your rectangle should be on the graph.
About the right.
Right hand, then it would start like a right hand one on this graph. The top of your rectangle starts here. And then you got like draw it that way. So that would be 1, 2, 3, 4,
Oh.
5.
Top of the rectangle. Put it on this
Top right of the rectangle touches the graph for a right hand.
With the top left.
Yes.
Okay,
Yes.
that makes Brian was trying
Huh?
to tell me about
Why do we have pi day?
Why do we have Pi Day?
Yeah, my face is gonna be so broke out from all this sugar, man.
That's your own fault.
If I walk in looking like a demon tomorrow, it's because of all the sugar I had.
Okay.
Ain't nothing we ain't been through before.
All right. So number 2, we kind of set up and talked about together, right?
I got 412.
Yeah, 402.5.
Yeah, as long as you're within that, that's fine. It depends on what sum you used, and that's okay.
Wait, so what did you get?
I got 402.5. If you did a trapezoid, you should get 407.5. I'm guessing if you did, what'd you do, left or right, Daniel?
I did the things that are like look like this.
Midpoint?
It's like the triangle.
Trapezoid, you should have got 407.5. But as long as you're close in there, that's fine. I'm not super worried about it. Okay, so then for number 3. So I helped you draw the rectangles on these, right? So at pi over 4.
1.
What?
2.6.
What?
00685.
Again, I say, what? So the function value at pi over 4 is 0.38268. Were you guys in radians when you plugged them in? Did you plug them in?
I just did not. I don't know.
You had to plug that. You had to plug it in. So you should be doing sine of pi over 4 over 2.
Oh, I bet I did it. Would that give you a 20
Oh, no.
Yes.
I was talking about the last answer. Sorry, my bad. I did get 0.3. 1.38.
Right. And then at 3 pi over 4.
0.92.
Yes. They did 5 decimal points. Probably just to keep it as exact as possible.
And then it's 0.38 again.
Do you multiply all those by pi over 2?
Yes.
It's 2.6, right?
Yeah, so multiply all those by pi over 2 and then add them together.
Multiply all those by pi over 2?
Yep. So, or you can, I would personally add them all together and then multiply by pi over 2 one time. So add all these
Oh, I might have not.
and then times pi over 2. So that should give you 4.10468. And if your calculator wasn't in the right mode too, that would also mess you up.
1, -1, 1, -1.
Oh, yeah.
But
It sounds like you plugged in, it sounded like you plugged in pi over 2, pi 3, pi over 2, and 2 pi.
Harmony.
Or you multiplied by 2 and didn't divide, because like that sounds like,
because
it sounds like you multiplied by 2 instead of divided by 2 when you plugged it in.
Oh.
That's exactly, because then that would have given you those values, and then that's where you got those numbers.
Oh, it is that.
That
It was
makes
like
sense.
sad.
So, yeah, Sam, that's what happened with yours.
okay.
All right, we ready for number 4?
Yes.
Okay. All right, so number 4, you were doing trapezoids. Okay, from 0 to 2 with 4 partitions, right? So let's split it into fourths. So we're going here, and here, and here, and here. Okay, so we're doing trapezoids. So it almost goes right along that curve, which is kind of nice. Like they're a little bit off, obviously, because it is technically curved, but
I actually might have done this one right.
What are you doing?
okay. So then, each of these has a width of what? 0.5, right? So remember, for the trapezoid, we multiply everything by half because that's part of the trapezoid formula, right? And then times, we'll do it 0.5 just so we remember where that one came from. Yes, and then we have, let's see. So I'm going to check them off. So 4 for this one, right? And there's just one of those. Yes?
Yeah.
And then we have 2, and then we're plugging the 0.5 into our formula to get the exact height of this.
Oh, well.
So it should be 2 times 4.41.
Oh,
Well, that was close.
I did 4.5.
I have 4.2.
Yeah, so you guys should, if it gives you a function to plug into, then you need to plug in. If it doesn't, it's fine to estimate it.
Where's the function?
Oh, it does.
So what do we plug into the function?
So for that one, you would have done 2 to the 0.5 plus 3 to get that one.
So then what are you doing like, oh, so the next one you do 2 to the 1,
Yes, which would just be
5.
5.
Oh,
So that's that one. And then 2 to the 1.5 plus 3 is 5.82. Right, and then the next one is 7. And it's just 7, right, because there's only one of them. Okay, so then when you do all of that lovely math, you get 10.37. So, were you guys all close to that?
Sort of.
yeah.
Right. So again, if it gives you the function, you need to plug in to find the height of
That makes sense.
Why is the last one just plus?
because we don't have to double up on this one. It's just the 2 outside ones we only have to use 1 time. You only have to do 2 for the inside ones. All right. So now let's move on to number 5, shall we? Okay. You guys might want to check on your cheesecake on the heater and make sure it's not like melted.
The bottom's gonna be warm. It's gonna be ooey. And the middle's just gonna be solid. We're gonna drop it. It just isn't right. It just falls down.
Let us see.
Okay.
I don't care.
So, number 5. The table below shows the velocity of a small camera drone as it traveled down a golf course fairway for 60 seconds. Estimate the distance traveled by the drone using 6 partitions and the methods below. So, 6. I'm going to let's think about it. So, from 0 to 10 would be like 1 rectangle, right? And then another 1, 3, 4, 5, 6, right? So then for a left-hand sum, so it would be 10 times
So you can do the graph like that.
Kind of, I mean, I just kind of did that so I could like try to get a visual for how my rectangles are going to be. Like, and how I'll have 6. That way I don't get confused. So, starting on the left then for our first one, we would start at 0, right? So, 0 would be our first rectangle, right? Then 28 would be the second. 31 would be the third. 33, 23, and 27.
Oh, I might have done this right.
So then you get 10 times 142,
I did this right.
which is 1420.
So
We're geniuses.
you
We did it like such a long
kind of
way.
draw a graph.
You could if that would help you, yeah.
And it's immaculate.
I just looked at what they did on the example before and figured it was right. And then I guess it kind of might have.
This is the first time you'll ever see calculus students eating frozen cheesecake.
All right, so then for the right hand sums, right? So again, 10, and then we're going to use 28, 31, 33, 23, 27, and 15.
Hey, jeez.
All right, guys.
We did this right.
All right, good job. All right, so then we're good with 5. You guys feel okay with that?
Yeah.
Better than we thought? Okay. All right, number 6. Okay, so then for 6, we're using midpoints. That's fun. Okay.
This chair's pink.
Yeah, Sam spilled his protein shake on it. It's fine.
And then the cleaner that I used really made my hands break out.
I'm sorry.
I should have lost my hand.
All right. Andy and Bobby were riding their motorcycles near somewhere in North Carolina, blah, 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 blah. Okay. No. It's fine. All right. So then, thank you. The table below records the time needed to stop the bike before attempting to maneuver the 318 curves. Woohoo. Estimate the total distance needed to stop the motorcycles by using midpoint rectangles.
Don't tell me I did this right.
I think this is where I started getting it wrong.
So they broke this up into 3 rectangles instead of like 5.
Yeah, so maybe I should put it right.
So they did. Yeah, absolutely. So they did this, this, and this.
That means are you going to use 76, 43, and 12?
Yes.
Yes!
Yeah, so then they're using the ones kind of in the middle there. If you're going from 0 to 2, then you're going to use the value at 1 and 3 and 5. So we're using the ones literally in the middle. So each one is a width of 2, and then add those. So you get 262.
Oh, we still. Oh. Wait.
Oh, I got
We were close.
272.
We got 272. Because we didn't know you were supposed to skip. How did y'all even like get to that conclusion?
So my thought is if I have to use midpoints, right, I want to pick something that I can, rather than having to like add and divide by 2 to find like, and I don't really know the shape of that graph. So I'm going to go from here to here so I can make 1 my midpoint. I'm going to go from 0 to 2. I'm going to go from 2 to 4, and I'm going to go from 4 to 6, and then make my odd ones my middle.
Do you remember that example graph we did? No. We did one of these.
I'm going to need some more specifics, Daniel. We've done a lot.
Well, it was like right before this, and they just skipped over the steps, so I didn't copy it back in.
Okay. Good deal. All right, so then number 7. Oh, sorry. Okay, number 7. Table shows the rate at which gas is leaking from a punctured gas tank. right-hand sum was used to estimate the total number of liters that have leaked from the tank. What is the estimate? So 1 rectangle, 2 rectangles, 3 rectangles, 4. They are each, they're a different width.
Yup.
The moral of the story is this is really easy. We just made it really hard on ourselves. So we had like drew a graph for everyone. We're not freaking out.
Okay.
Freaking out. We're like,
Yeah, all right. So the first one has a width of 1.3, and we multiply that by 4.3 because that's our right-hand number. Thank you, Mia. And then the second one has a width of 1.1
Yep.
times 3.2, then 1.3 times 2.4, and 1.8 times 1.6. So you get 15.11. I did 2.4 minus 1.3. I'm like finding the width between these two.
we did something. But we got the right answer. So then you did 3.7 minus 2.4.
Mm-hmm. Yep.
We did something. We got it right. I don't remember how we did this. Is this Monday or Friday? No,
Monday.
1.3 times 4.3 plus 1.1 times 3.2 plus 1.3 times 2.4 plus 1.8 times 1.6. Look what I put.
All right. How far did I have you go?
8.
8?
I actually wrote
I guess I could have had you do more.
No, I only did the whole class.
Okay.
We did fast.
Yeah, because I was a little different, so I was afraid you guys were going to panic. I was surprised I didn't get any panicky emails.
Well, we were going to send you one, but then Cody was just like, she probably did not know she did anyway, so just go ahead and try. So that's what we did.
Yeah, you guys tend to do okay when you're forced to figure it out yourself. All right, and number 8. So. Okay, guys. Shh. I'm going to make you sit by yourself.
Did you know there's a scooter club at Hogwarts?
No, but I'm not surprised.
It's called Scooting for Concord.
That's honestly hilarious.
I would enjoy it.
Do it. Okay, number 8. Da-da-da. What are we doing? Okay. Use the midpoint method in 6 rectangles. So, 1, 2, 3, 4. So, midpoint just like we did before. Right? Like just like we did in, what was it, number 6?
Yeah.
You made this so
I'm not surprised, but so each one has a width of 2, and then we're multiplying by our midpoints, which are these ones in the middle. So 2.4, 3.2. I can't believe you all drew graphs for all of
I
these.
did. I just did this.
Mine's a monstrosity.
Miss Lauderman, if
Yeah.
you look back at that other graph, you could do it from the example one. That's how I just looked at that one and said
Yeah.
it looks right.
So did we end up with something like this? Probably not. Did you get about 39?
39. Yes, let's go.
I didn't do midpoint. Me and Amelia didn't do midpoint. We just did like everything. We just kind of did our own thing.
Oh, well, okay. I mean, all right. But do we have a better understanding now?
Yes.
Much better?
Yeah. I knew what I was doing other than-
Comfortable enough that we can take a fake test on this tomorrow?
Yes.
Is that why it's called IXL? IXL.
I don't know. I didn't name it. I just make you use it. Okay.
It's probably like something that.
Are we done for the day? Out.